not given us this deeper, deeper, and I want to say more valuable sort of insight into electromagnetism, which is really his work called The Special Theory of Relativity, which gave us this very much deeper and novel, and at that point, the first really sort of insight into how light works. And he basically took the current theories of electromagnetism, the work of James Clerk Maxwell, Michael Faraday, and others who had already been working on electric and magnetic fields and told us that light was an electric and magnetic field. Light was basically oscillating electric and magnetic fields, like it was the electromagnetic wave. But then this deeper understanding of, well, they used to think that we needed some kind of medium for light to travel through, for like what is waving, what sort of thing is vibrating or waving for light wave to be a thing. For example, sound waves travel through certain kind of media like air or some other material. It can even sort of shake the wall, right? And that's a type of sound wave. So basically, people were not familiar yet with how light can be a wave and travel through space and stuff. So it was incredibly insightful to learn about light further in The Special Theory of Relativity by Einstein, especially because until that time, sort of the two things, the two big things, one was Newtonian mechanics and the other was electromagnetic theory. These two were sort of at odds because Newtonian mechanics said that if you just ran really fast, maybe you would catch up to light. But then Einstein said that the speed of light in vacuum is a constant regardless of how fast you're going. Regardless of the frame of reference you're in, the speed of light is a constant. It fell out of the equations of Maxwell. So it was sort of already a reality, but Einstein had that sort of vision and thought experiment where he was like, no, but listen, the speed of light is a constant. Like, do you hear me? It's a constant, even if you or the observer is traveling very, very fast and you cannot, in fact, catch up to a beam of light that's traveling in space. Hello, Felipe. By the way, guys, if you want to do a super chat, most welcome to. If you want to like the live, most welcome to. Can we get 20 likes? Can we get 20 super chats? I don't know. Go for it. Feel free. He's currently the president of the Origins Project. You can't find my email? It should be there on my YouTube description. What's... Oh my gosh! What is that? What is this message? What are you doing, Darth Margus? So I am Melon. My email is my first name, then B, which is the B, just the letter B, at gmail.com. And hopefully you do find it on my profile. We doing this. What are you talking about? What are you doing? So let's keep going. So as we will discuss in chapter 2, Einstein resolved this conflict through his theory of special relativity, and in doing so completely overturned our understanding of space and time. The fact that the speed of light is a constant, and that means that space and time are relative, is what we get out of the special theory of relativity. And it's very interesting. It gave us all this deep new insight that I'm mentioning here. And it really quite changed our lives and understanding of physics. According to special relativity, no longer can space and time be thought of as universal concepts set in stone, experienced identically by everyone. Rather, space and time emerged from Einstein's reworking as malleable constructs